Hey everyone, figured I'd do a bit of an overview on a board I made called the RAMPSXB, the Ramps expansion board. So anyone who's done any decent work with 3D printers will recognize this. This is the Ramps, the RepRap Arduino Mega Pololio Shield. It's generally considered to be one of the lower end boards, but when you're trying to get into printing, this is pretty much the first thing you'll run into. It's dirt cheap. It's like $7 for the board. And then these drivers, just maybe $1.50 a piece, and this thing is, $8 depending on where you get it. China just spits these things out like crazy and runs like half their printers on them. So it's not a good board, but it's a well-known. I think it's the most common 3D printer controller in the world, and it's somewhat reliable. I've actually been using a Ramps board on my printer for the last 2 years, and it hasn't had any issues whatsoever. There are issues with manufacturing, like trace widths. Traces do burn up, that kind of thing. But I'm not reviewing the Ramps on this board. I could just complain all day. So the issue that I ran into with this board is that I do a lot of testing with strange kinds of printers. Like I try and adapt printers to do servos or try and do some other crazy stuff, and I always run out of functionality on this board. So I figured I'd try and expand functionality a bit while still making it easy for people to use the expansion board that I wanted to put in. I originally had this idea about a year ago, but I didn't really know enough about board design to actually make it. So I figured I'd teach myself Eagle with this project, and I think it's been pretty successful. So, kind of just to start off, this was the first version of the board. The things that I really wanted on this were 4 additional thermistor output, or 4 additional four additional stepper motor drivers, like these carriages, places for these carriages. I really like this concept of having just a board that's nothing but pin headers, maybe some resistors and capacitors and discrete components, and just a bunch of pin headers. There's no processor on it to replace. If you fry something, you can just take the processor off and replace it, or the driver board and replace it, and it's really great for experimental machines. These things really can't be replaced that easily, but they don't burn out that often except for the heated bed one. So kind of just the goal was to expand that out. The parts that I wanted were the 4 additional stepper drivers and the 4 heaters to run them, and 4 additional thermistor inputs. This specific number kind of came out of a board that RepRap.me has produced called the Diamond Hot End. The original Diamond Hot End has 3 inputs, and they're all mixing together. But they came out with a new one called the Diamond Hot End Full Color, which is cyan, magenta, yellow, black, and white. So you can create any color that you want using that system. Which is great, except for the fact that you need 5 extruders and maybe a support material extruder also in order to make it work. So that's what, total of 6 extruders. Another example is the E3D Kraken, which is 4 extruders, which all need their own heaters and all need their own thermistors. So that's kind of where that number came along. I kind of wanted an SD card because I knew that this would consume the set of pins here, which are used for the LCD screen. So I put that in there, and then I connected up to here so I could just use an SD card because that's really what I wanted to keep. Unfortunately, I was an idiot and I forgot to step down the input pins to this. So they're all 5 volts, so this just fries any SD card you stick into it. You gotta make some mistakes, Down here, there's 12 volt rails. So the original Ramps board has a 12 volt rail down here, and I always consume that with like a fan or something. I always need 12 volts, and that's the only connector on this board that has it. So I wanted to add a couple more of those. So it just pulls it off, and it just pulls 12 volts out of this input here and distributes it. So has this nice fuse kind of thing, which unfortunately was lost in later versions because I didn't have space for it. But all in all, I think it was a pretty nice looking board, especially since I was trying to learn Eagle while doing it. But aside from the fact that it fries SD cards, The biggest problem with this board that I had was that these guys here are not connected to PWM pins. They're connected to digital pins. So you can use, bang bang control, but if you're trying to use a PID control that most printers would use, it doesn't work. So a lot of mistakes made, but in general, I think it was a good learning experience, but that's about it. This is the first version 1.0 of the RAMPSXB, and it was a good attempt, but you gotta make mistakes to figure out where you gotta correct them. So then I came across this board. This was the next version, and it fixed a lot of issues. It's got some big heat sinks on these guys so they can handle it. What I did was I went through, and you'll notice this board's longer than the original. The original kind of also consumes the like just aux 1 and aux 2 and 3, but this one expands out and takes up these guys here and the end stops. So kind of the background story of that was this takes, I needed pins. It's got a bunch of expansion pins, but eventually those things will run out after you start demanding a bunch of stuff from it, right? So this was version 2.0, and if you flip it over on the back, you'll notice that I forgot to wire some grounds together, so I had to do that after the fact. But all in all, it was this works, and it actually has a lot more features to it than I thought I'd be able to cram into a board. But before I mention those, I'm going to go to the production version, which is this guy, the original RAMPS. This is the RAMPS 2.1, but it's pretty much identical to the version 2.3 that's available now. Version 2.2 had a critical issue where one of these pins was actually pinned over here. I ended up fixing it, but it's just I had to. The version 2.2 no longer exists. Version 2.3 is the production grade version, which has these SMD MOSFETs. Version 2.1 was retroactively fixed from this issue. So this one's actually still being not really produced, but it's being supported. It's functionally identical to the production board. It's same in every way on the firmware. The only difference is that the MOSFETs are through hole. So anything on this board you can solder on your own if you just buy the components in a really, really thin soldering iron and you have like an hour of time. Whereas with this guy, you can solder most of it, but realistically it's just designed for production because these guys are going to be kind of complicated to solder on your own. So idea is you just take it, and you notice that I also exposed these traces, and I'll get back to this. You just take it and you stick it on the connectors here, and then all you do is just squeeze them down, and that's it. And it's connected to the ramps, and install the firmware, and it will behave exactly the same. So aside from adding the stepper motor controllers that I wanted, so the ramps board has extruder 0, it has stepper X, Y, Z, extruder 0, 1, RAMPSXB adds extruder 2, extruder 3, extruder 4, and extruder 5. It's for a total of 6 extruders. And thermistor wise, down here you got thermistor 0, thermistor 1, thermistor 2, and the RAMPSXB adds thermistor 3, thermistor 4, thermistor 5, and thermistor 6. So that's 6 extruders and a heated bed. Heater wise, down here we got heater 0, usually used for the heated bed, heater 1, heater 2, and over here we got heater 3, heater 4, heater 5, and heater 6. So again, that's 6 extruders and a heated bed. So these lights down here are the same lights that you'd find over here. So it will light up when extruder 3, 4, 5, or 6 turns on, or pulse when it's working. Over here, I added the breakouts that I was looking for, but instead of making, like, this 5 volts comes straight off the Arduino, so it just pulls it from the Arduino. This VCC output, though, I changed it from 12 volts on the original board to VCC because I realized that this board is not electric. The 12 volts on the XB is not connected to the 12 volts on the RAMPS board. There's no connection between those two, which adds the additional feature that if you want, you can add, say, 24 volts, or I guess 12 volts to the RAMPS board, but run 24 volts on the XB. So you can actually have different voltages. Another major revision is from the original board was that I did a pin count. I counted up all the pins I had, and I found out that I had exactly enough to get the LCD screen. I had to go find those pins, and the documentation on the on the full graphics smart controller is kind of terrible, but I managed to actually get those pins broken out and in place. And you'll notice that they're up here, and they're labeled EXP2 and EXP1, and they have these little notches on the silk screen right there. And as you'd expect, you just go to your board here, find EXP1, the little knob on the end of the connector goes to EXP1's connector, and EXP2, same little thing, little knob goes on EXP2 connector. Not terribly complicated. And then you just plug it in. Plug it in. There you go. Should boot up in a second. There it goes. So, and it works. I'm not sure how well you can see that on the video, but it connects to it and it behaves. It has all the same features, including the SD card, working on this setup. And you can notice if you go there, you can change temperatures for beds and all 6 extruders. So I was actually pretty glad that I managed to get that feature in here. So swapping back. Here we go. As for the end stops, I needed to consume the maximum end stops. No one really uses max end stops. They're there, but no one really uses them, and I needed the pins. But while I was at that, I figured I'd add in these guys here. These are little suppression capacitors. There's a board on RepRap called the Ramps 1.4.2, which is kind of a revision that fixes some of the issues with the Ramps board. And one of the things that it adds that I really liked is that it had these suppression capacitors that go on the end stops. So if this really isn't an issue with 3D printers, but it is with CNC machines. When you have a lot of current going through a wire, you induce a magnetic field around that wire. So if you have 2 wires running right next to each other, then the magnet, and you run a bunch of sharp square edge signals like a stepper motor wire, and you have a bunch of current going through it, it's going to induce a changing magnetic field around this other wire. And that's going to induce a current in it. And if you have that right next to an end stop, you're going to end up with your axes drifting off of place because it's going to think that it's getting triggered even though it's not, because it's inducing a current in that wire. That's not a huge issue, and I really haven't seen it happen on any of mine, but it's 3 capacitors, so I figured I'd just throw them in. The end stops here, the minimum end stops were all broken out and put down here. They're sideways, so it's set up so it's, instead of being down, down, down like they used to be, it's sideways. So this is X negative or X minimum, Y minimum, and Z minimum. And it's the same as you'd find on pretty much any end stop. It's signal, ground, power. So same as pretty much anything that you'd find, and you just plug your connector in. This is a polyfuse. There's not a reverse protection on this circuit, so when you apply your voltage in, this is where the input for the power is. Do not, see how it says down here, it's got the positive and the negative? Don't flip these backwards. Like, do not flip these backwards. Like, do not flip these backwards. I was going to add a reverse polarity diode, basically to prevent it from, doing anything bad, but I ran out of space. So if you flip the voltage around, you'll basically end up dumping 12 volts or higher into the ground here, and this ground is tied to the ground of the Arduino. So you're going to end up just pumping 12 volts into the ground of this Arduino. And that might not only fry this board and everything on it, but this board and everything on it, and possibly even your computer and everything on it. So just double, triple check to make sure that that's right, or you could really have a bit of an issue. So yeah, I mentioned polyfuse. That isn't here to prevent it from burning up, but Some people don't like polyfuses. I personally haven't had an issue with them, so no real problem there. I squared C pins, they used to be in this line here. No one really uses these except for anything like thermocouples. So I did break them out. They're down here, but they're a square instead of a line, and they're marked there SDA, SCL, plus 5 volts and ground. Kind of the same. What else? All right, down here. This is I again just needed pins to fix the issue that I didn't have enough. There's no PWM pins anywhere here except for pin 44, and that one actually drives this guy way over here. But the only other PWM pins on the ramps board are the servos. So I had to go eat up those servos. People really don't use servos for anything except for auto bed leveling, and when they do that, they only really use one. So I kept this servo here, the first servo 0, and I pulled it out, flipped it sideways, and stuck it right there. Same setup. It's got the S right next to it. This is signal, and then it's ground. It's signal, power, ground. So it's the same, but I just consume the other 3 servos to drive these MOSFETs with PWM. I also broke them out here. These little holes here are broken out of these 3. There's not really a reason for that, but I've sometimes needed PWM pins and not needed all of these. So I figured I'd just break them out so I can get to them. If anyone really needs those, it's fine. If not, it doesn't really matter. Just ignore them. Then there's the serial, the RX and TX signals, and people sometimes use those for Bluetooth connectors. So if you've read the RAMPSXB or the RAMPS board's wiki page, you'll notice that there's a setup where you can attach one of the legendary HC05 chips, which are dirt cheap, and you take them and you feed them. But the thing is, you have to step down the voltage for the input for this, which is the RX line on this guy and the TX line on this guy. And otherwise you'll just fry this board because it can't take 5 volts receiving. So I figured, you don't really use it for anything else, and if you do, you can probably read anything that reads 5 volts off of 3.3 volts. It's above the threshold to be considered a high signal, so it should be fine. But to just connect it straight up, there's these 2 here. This is a voltage divider. It's just a straight up voltage divider that takes the TX out of the Arduino and steps it down from 5 volts to 3.3 volts. Not more complicated than that. It's really designed so you can just take this HC05 chip and then just line up the middle 4 pins and then just dunk, and that's it. You're done. You're good to go. All you have to do is define it in firmware, and you can talk to it. So it should start flashing. There it goes. So designed to be easy, designed to be simple. Just shove it in the board and you're good to go. All right, these traces on the bottom here. So when working with this board, I wanted to keep the size kind of as small as possible because it does have to fit in casings and it has to fit, around an actual system. The problem I ran into is that the power traces on these here output, I'm not sure exactly what the exact current output is, but the thought was for 4 30-watt heaters. At 12 volts, a 30-watt heater draws what, 2 amps? 2 amps, somewhere on that. No, let's say 40 volts, just to be safe. Let's go say 40 volts. At 12 volts, that's sort of 40 watts at 12 volts is about 4 amps. That's kind of an overkill estimate, but it's roughly right. So 4 amps per heater, there's 4 heaters, so that's a total of, what, 16 amps coming through this thing, which is quite a bit. And that's obviously a huge gross overestimate, but I actually did testing on these, and I think they can pull about 12 amps before they start getting hot. No, it's about 9 amps before they start getting warm. I did a very primitive test where I basically just stuck my finger here, and then I ran, short-circuited these here with a voltage, and I measured the current limited it, and then cranked it up. At about 9 amps, this started to get warm enough that I could feel it, and about 12 amps, it got so hot that I couldn't touch it. At that point, you really can't go over 12 amps with this baseboard. However, these traces are exposed, and the reason for that is because you can take them and cover them with solder. Basically, just run along with a big soldering iron and cover up all these traces with solder, and it actually increases the output power you can get. I ran the same test, applied power here, did this, and at 12 amps it started getting warm, and about 16 amps it was so hot that I couldn't touch it. So it does increase your ability to pump out power, but still, regardless, I would not advise running a heated bed off of this board. Just use it off of the ramps board connector. It's better. I know it's not perfect, but it's better. These guys are really designed to run fans or at most 40-watt heaters. So if you really need to run anything more, or if you need to pump out more amperage, I would advise, instead of that, using 24 volts on this connector, and then it just cuts that amperage in half, and then you're fine with pretty much anything. So everything, all the connectors here are pretty much copy and pasted out of the schematic for the ramps board. So all these guys have the same setup underneath the hood here of just the 3 jumpers, and you know it works exactly the same way. The thermistor inputs right here are the same capacitors, the same everything. It's identical to this board, just replaced. The only difference is the actual MOSFET heater types. Obviously, these are SMD component versus this. I haven't really done any heat testing on these guys yet, but from my experience, they seem to work out just fine. But if you have any issues, let me know, and I can see if I can do something about that on the board. So as for installing the software on this, or the firmware, the only firmware that I know of that can support 6 extruders is Repetier. Everything else, including Marlin, seems to not like having more than 5. So I actually put up a version of the firmware that will run this machine, that will run a full 6 extruder machine off of a ramps board. It's up on the wiki page. You can just download it and try it out. If you want to adapt your own firmware to this system, there's some minor changes you got to make, and those are also listed on the wiki. It's basically just redefining pins. These pins are all kind of distributed around here because the step and direction pins can be any digital pin, so I just started burning up pins wherever I had them. Down here is D40, and it's broken out, as you can see there, and that is the only pin on this board I did not consume. So if you're like, oh man, where are all the extra digital pins? You can either use these guys here instead of the LCD, or you can use digital 40. If you need anything else other than that, you're pretty much screwed. Or you have to find a way to break into these stepper controllers. So that's pretty much it. One of the things I wish I could have added was these through holes here. This hole just goes all the way through the Arduino up to the ramps, but there's a bunch of wires there, and I couldn't get through it, and I couldn't find a way to reroute it. So in order to actually screw this onto any panel, you'll have to take the XB off, screw it into the panel, and then put the XB back on. But that's about it. I'm kind of just field testing this now. As a warning, down here, this is the main power input trace, and then it jumps to this. This distance here is the fuse. So the fuse goes across that, down here to these guys, to this ground plane where it sinks some heat from MOSFETs, then up and around, and then back to the other side. The issue is that these two wires are really, really close together, like really close. and it would be very, very easy for you to accidentally jump those wires, and then you would basically just be short-circuiting your power supply because you're just jumping over the fuse. The fuse won't even catch it. So just be very, very careful when we're working with those, and inspect that joint to make sure it's not jumped before you try plugging it into any power. So there you have it. It's the RAMPSXB. It's actually being sold right now by reprap.me. You can just go to reprap.me and look for RAMPSXB and you can find it. It's not terribly expensive. The whole concept was to make it just discrete components, these heater components, and then just a bunch of pin headers. You can make it yourself, but you'd want the version 2.1, which is going to be a bit easier to get these MOSFETs in place, and I think it does a bit better job sinking heat because of these heat sinks. But overall, I think it was a pretty good success, and it's fully open source. If you got any questions about it, or you have any suggestions or things you think are not the best idea, or things you think would be a great idea, feel free to let me know. Make your own fork, or do a pull request, and I'll take a look at it. So thanks, and thanks for watching, and if you need anything else, any questions about this board, feel free to let me know.